So we need to work out what this angle here is so that we can work out angles on a straight line, because I can't do anything with that bit there. How can I go ahead and work out what this angle here is?
C-shaped.
Excellent, well done. C-shaped interior angles is the proper name for it. Add up to 180. So we'll call that angle, well, what angle is it? It's going from D to C to E. So D to C to E is equal to 180 minus 76, because that's much quicker, isn't it? Yes. Right, so let's do Lewis's way. Okay, so we've got a Z angle there, so that angle there must be 76 degrees. So let's change that to B to C to E is equal to 76, because what's the proper name for Z angles? Good. So when you see Z, I think A to Z being the A is alternate angles. Okay? Alternate angles are equal. Okay? Right then, so if that's 76, then this is also 76, because
it's an isosceles.
Good. B to C to E equals 76. Do I need to say exactly, do I need to write this in a proper full-on sentence?
No.
Why not?
QWC.
Good, it's not QWC, so don't waste your time. So let's go and work out this angle by here. So I'll do 3 lines there because they must be different again. So we would do 76 times 2, or 76 add 76, whichever way you want to do it, which would be, what, 12, 152. And then we do 180 minus 152, which is 28. So angle B, so that's E to B to C, is equal to 28, because, good, angles in a triangle
Yes, it does, because it adds up to 100.
equals 180. Final bit, how do I go and work out X? Good. 180 take away 28 would be equal to, what, back to 152, isn't it? Equals X, because angles on a straight line equal 180. Okay?
So can that be used as a general rule if you have like an isosceles, that the exterior angle of
It's not something that can work every time with isosceles. It's every triangle. I wasn't actually going to mention it because I figured I could say it and it could confuse people this close to the exam. I'd stick with what you know fundamentally, but this angle on the outside is always the sum of those two added together. Okay? Because of the rules being 180 and 180. Okay? Page 19 now. Oh, good. These are 2 of the topics we said to most likely to come up. I won't do part C because obviously we don't know what the previous question was. So this one here, a lot of you do your own method for this. Fine, whatever works for you. Like I said, don't change what you're currently doing. For me, I leave a couple of lines first. Say x equals 0.34646. And then I'm going to times mine by 100 because I've got 2 dots. So the number of dots there is the number of zeros you have here, so 100x there. Get the equals and the decimals lined up. 2 times it by 100 would move that on 2 places, so that would become 34. And then 6, and then after 6 is 4, 6, 4 and 6, so they line up again. I subtract those. So these are all going to cancel here, but then 3 take away 6 is going to be 3. And then 34, that would be 99x. So x equals 34.3 over 99, but currently I only get 1 mark because can't have a decimal in a fraction, so times both by 10 is equal to 343 over 990. Okay? Like I said, don't change to my method if you're happy with yours. No point. What does squared mean? Times by itself, so that's going to be 7 minus 5 root 2. 7 minus 5 root 2. And then you're going to expand that bracket. Okay, I'll give you a little bit of a head start. Have a go. Go on, Anthony, start me off.
14.
You've done it all already?
No.
Oh, I was going to say, okay, so 7 times 7 is how much? 49. And then 7 times by minus 5 root 2. Any ideas? Minus 35 root 2. And then minus 5 root 2 times 7 will give us another minus 35 root 2. And then this one, the one you've got to be careful with. Minus times by a minus, plus. And then 5 times 5 will be 25. And then root 2 times root 2 be root 4. I'm going to leave it as 25 root 4. But it's absolutely fine if you want to write that as 50, which is going to be in a second, because root of 4 is 2. 25 times 2 is 50. Okay, but some people will skip straight to 50 there. So I'm going to have 49 minus 70 root 2, and then plus 50, which will give me finally, it will give me 99 minus 70 root 2, which is, because? Good. The definition for being rational is an integer divided by another integer, a whole number divided by another whole number. So that means the fact that we've got a root in there straight away tells us it's irrational. That's why you do surds. It looks neater. Okay? Page 6.
Oh, I love this one. That was on the mark. Yeah.
What, the knife and forks one?
It was the one that we did in. No, it was in the mark. It was in the mark.
What's that?
No, it wasn't. Yeah, it wasn't.
Okay, so the bearing of a name I can't even say from cum is 235. Write down the opposite, basically. Write down the bearing of cum from Rayton. If it was me, probably would use a protractor if I had one handy. I haven't got one handy. I know that 180 is going to be there, so I'm just going to have a guess and say that 235 will be somewhere around here. Now that says from cum, so that means I need to measure clockwise 235 degrees, and that is my new place here, the Rayton place. Okay? So what it's asking me now, it says write down the bearing of cum from Rayton, so I need to now place myself here and measure from north here. Okay? Now, if you did actually go and measure that here and measure it again, you're probably going to do it wrong. It wants you to use parallel lines here. Okay? So if I was to sort of split this up a bit more into a straight line here and here, then I can tell you that this angle here would be the same as this angle here from doing Z angles. But how could I go and work out this angle here?
Couldn't you also continue drawing the line and it could be like that?
Could you just do 360 minus 235?
Okay, 360 minus 235 is?
No,
Go on, 125. So that's 125 there, and then we could use interior angles add to. You did tell me before, 180, so then that would be what, 55 here? That's one way of working it out. Or you could have said 235 take away 180 is also 55. Angles on a straight line add to 180 here as well. So my bearing of come from Rayton is 55 degrees, but I've missed out one really, really important bit. 055, because they have to be 3 digits, okay? Should we stick on number 5 as we're here? Looks fussy as well. So it says, in a factory there are 2 machines. Machine A makes plastic spoons, machine B makes plastic forks. They work at a steady rate. So machine A makes 180 plastic spoons per hour. Machine B makes 240 forks per hour. Both machines start their production on a Monday at 9 AM. Both machines stop for maintenance after 450 spoons were produced. Calculate the time at which the machines will stop for maintenance. The number of forks produced between 9 and that time. Okay, so
So this was on homework.
yeah, it was, wasn't it? 7 marks. I need to try and see that as much as I can, so I can do the answer, but then also we need to see my writing. Okay, so what am I going to do first of all? So it makes 450 spoons. So 450 spoons would take how long? How do you work that out? 450 divided by? 180, that's exactly what you need to do. You know that 180 spoons takes 1 hour. Okay? You've done that awful quick that you managed to work out that's 2.5. I'm there thinking, no, how do they do that? If it was me, I'd try and maybe double this one here to say 360 spoons would equal 2 hours, and then 90 spoons would equal half an hour. Okay? So then adding those two together gives me 450. Need to write all my answers in properly, don't I? Why do I need to write in all my answers properly? QWC. So that's 2.5 hours. Don't worry, another lesson of this now. Time before maintenance. Okay, so I've done that. I'm not setting out my work as neatly as I'd like to. I need to improve my game here a bit because it's not logical and easy to follow. In terms of what I'm doing, at least it could be better, couldn't it? Okay, so I'll try and make a bit of a better effort for the next bit. It says the time at which the machines would stop for maintenance. So I know it takes 2.5 hours. They started at 9, so machines started at 9. So or 9 a.m. So stops at 11:30 a.m. Happy with that? Tell me if I'm wrong as well. It says the number of forks produced 9 at the time that stopped for maintenance. Okay, so I know that in 1 hour I make 240 forks. So in 2 hours I make 480 forks. In half an hour I'm going to make 120. So 2.5 hours I'm going to make 600 from doing 480 add 120. So look, I'm showing that my answers come in here. It's not just popping up from saying 600, I'm saying where it's come from. So I'd say by 11:30 a.m. 600 forks have been produced. Now, in terms of do I need to talk through what I've done again? No, it's all here. That is obvious what I've done there. Okay, there's a point of writing out the same thing twice. Have I done everything they needed to do? Go back and check. It's just 7 marks. It seems like quite a lot of quite little work for 7 marks to me. I don't think that's a huge amount of work. Should we check the mark scheme as well? Is it number 5? Okay, so did we get 600 forks? Yep. Did we get 11:30? Yep. So 1, 2, 3, 4, 5. So there's our 5 marks. We've done that. And then it says QWC candidates will be expected to present work clearly, maybe with diagrams and words explaining the process or steps. Okay, so how could I maybe improve my answer to make sure I'm getting that QWC2 for definite? Show what I've done to get 450. So, yeah, I would probably, in hindsight, I'd go around and say that 180 spoons equals 1 hour, and then I'd show that I've times that by 2, times that by 2, and I'd show here I've divided that by 2, so I've divided that by 2. Is that starting to show a bit more coherently what I've done? Answers aren't just popping up out of nowhere? And then I could do the same down here, couldn't I? So this is the sort of thing that, you know, answer it first, be reasonably confident when you first answer it that you've got all those marks, and then if you've got time at the end and you're just twiddling your thumbs, go back and just add a few more things to really make sure that you've hammered home your points. Okay? All good? Should we go to the back again? You remind me to go on to the next page. There's part C for this as well. Okay, so what word am I seeing straight away that I know I need to write down a formula for? Histogram. So as soon as I see histogram, I need to write FD equals F over CW, isn't it, Maddie?
GW, sir?
CW, yeah.
G.
C, yeah. Okay, so it says calculate how many telephone calls were made to the computer helpline during Friday evening. Okay, so this is all the phone calls here, but this is measuring against frequency density. So the common wrong thing to do here is that you just come off and read the frequency density. So you say 1 plus 6 plus 10 plus 4 and so on. But we need to rearrange that formula. So frequency would be the same when I bring that divide by class width over, it become a times by class width. Okay? So read off the scale, make sure you have read it as well. It looks like 1, but just be certain. 1, 2, 3, 4, 5. 5 little squares in there. The whole thing's 10. Half of 10 is 5, so half of 2 is 1. So that is going to be 1 times by 10, which is 10. So I just write in how many are in the bar. Like that. 6 times by 10, which would be 60. Then 100, 40, 20. And then the last one, how much is this?
20.
Also 20, good. Okay, so then to work out how many are there altogether, it'd just be 10 plus 60 plus 100 plus 40 plus 20 plus 20. And when you're doing this in your head, try and look for things that add up nicely. So 60 plus 40 is 100, plus the other 100 is 200, 220, 240, 250. Okay? Estimate or calculate an estimate for the percentage of telephone calls that lasted longer than 3/4 of an hour. They're trying to trick us. 3/4 of an hour is
45 minutes.
45 minutes. They've done everything else in minutes. Okay, so you come to the graph, find where 45 is. So by here, and it says longer. So we're interested in these people here. Okay, so these 20 people here, but this bar's now been split. How would I split it? 10 and 10 because it's halfway, wasn't it? If it was, say, like 48 minutes, you draw the line at 48 and you do this formula again, the one at the top, frequency equals CW times FD, to work out how to split the bar. Okay, it's just been quite nice for us this time that it's bang in the middle. So that is 10 plus 20, which is 30 people out of X out of 250. So it's 30 out of 250. I need to write that as something out of 100. So how am I going to do that?
Why have you done plus 20?
Why have I done plus 20? Because these guys are longer than 45 minutes as well, aren't they?
Oh,
Okay? How am I going to change that into something out of 100? I'll probably divide by 10 and times by 4 would be my personal preference, because that makes it 25, then times by 4. So that would be 3 out of 25, and then 12 out of 100, so that is 12%. Okay? Estimate the median length of a phone call made to the computer helpline during Friday evening. Okay, so how do I find the median? What do I do? That's just a murmur from everyone. How do you find the median?
Is it half of 250?
It's half of 250, okay? So median equals 125th call, okay? So I'm looking for where number 125 is. So up to 10 would be here. Up to 60 would be here. No, it wouldn't. Up to 70 would be here because I've already had 10. And then it's 170 by the end of this bar. So that's no use. So the 125th person had to be in here somewhere. Okay? Let me write that bit. Need to 125th. Okay? Now, I know that 70 people have already been taken up to here. So how many people are left to get up to 125? 55. So I want to split this 100 bar into 55 this side and 45 this side because it was 100 people in there originally. So that comes down here, but I don't really know what that is. I can't go and use the scale there. I'm going to have to use this formula and tweak it a little bit. Any idea what I might do? Well, I know what the frequency is. It's 55. That's what I'm looking for. And I know what the frequency density is. It's 10. So I need to get class width on its own. Well done. Go on, David, tell me what it is. Class width equals?
When you figure it out to 10. Frequency divided by...
Frequency density, well done. Okay, so the frequency is 55 divided by the frequency density, which is 10. 55 divided by 10 is 5.5. So that class width must have been 5.5 here. So what's 20 add 5.5? 25.5. For me, that's probably been the hardest thing we've looked at so far today. 25.5. If that comes up and you don't get it, they're not the marks you should be going, oh, I can't believe these really easy marks came up on histograms. That, like I said, that's tough. That, for me, is the toughest thing we've looked at so far. Okay? All good? Okay, hopefully a little bit of a break now. For me, I have to use tracing paper for this. I can't do it by eye. If you want tracing paper,
Oh, because he added the.
Lewis has got them, so just ask him to plug in. Okay, so the key things to pick out with this question was that it was 90 degrees, it was anti-clockwise, and it was about 2 minus 1. And just be careful, you'd hate to lose a mark for plotting this wrong. I do see higher tier kids now and again plot this wrong. 2 minus 1 would be here. And when I draw it, I go and draw crosshair on here because it splits it into 90, 180, 270 and the rest here, okay? So now, tracing paper going over there, tracing the shape, and tracing the crosshair, and then anti-clockwise, spin it around this way, and it's just one cross over there, so it should be by there. Okay? So I'm just matching it up with the trace paper, just making sure I'm doing it in the right places. But you're going to use pencil to do yours anyway, so if it is wrong, it's not the end of the world. So when I trace that now, draw that in. I'm going to go and check by just putting my tracing paper over it again. Yeah, it's in the right place, isn't it? Okay. Next one says, enlarge a shape, enlarge the quadrilateral by scale factor of a half. Josh?
So you just making it smaller by 2.
Good. When you enlarge a shape, mathematically, it can actually get smaller. If you make something half as big, it's going to be divided by 2, isn't it? For me, I always go and pick the closest point to it. So I'm going to go from B, I count down 2. That's a distance of 2 and halve it. So that'll just be 1. Okay? Now you could do that for every single corner, but it takes a long time. What I do is look at the original shape. So this being a line of 4, 1, 2, 3, 4, halve it. Just half 4, 2. So from my enlargement corner here, that's now got to be 2. This one here, 1, 2, 3, 4, 5 and 6, half 6, 3, so I need to go 3 from here, 1, 2, 3. Now this is when my method doesn't work very well. If you've got a diagonal, it is very, very easy to mess it up. Because it's not a true diagonal, it's not going through the corners or anything, I'm not going to go anywhere near it. I'm going to use the same method I used at the start so I don't mess it up. So how do I get to this corner? I go across, 1, 2, 3, 4, and then up, 1, 2, 3, 4, 5, 6. So I went across 4, up 6, I now need to halve that. So half of 4, 2, 1, 2, half of 6, 3, 1, 2, 3, here, and joining it up. And it should look like it has been shrunk, like it's been pushed in from all corners, not like it's been like skewed or like skinnied or fatted, or they're not even words, are they? Okay, but you get what I mean. Thank you, Laura Jane, for laughing so hard.
With the diagonals, can't you just like the rise over runs?
No, you can do that, yeah. So if you went and looked at this and you said, right, that goes across 1, 2, 3, 4, 5, 6, 7, 8 and up 2. So here it has to go across 4 and up 1, isn't it? 1, 2, 3, 4, up 1. Okay? Well done. Well, we've had a present of all the pieces of tracing paper in my drawers today. Okay, you will be given tracing paper in the exam. If you haven't asked for it, you're allowed it. Should we go back to the back? Yeah, that's a good one to do. What do you think question 15 is? Horrible. It's easy. Nope. Simultaneous equations. How can you spot it that quickly then, Karan? How did you know that's simultaneous equations?
Because it's given two sides and two right.
Yeah, it's given x's and y's and perimeter. If it asked for area, then it'd be really hard. It'd be doing quadratics, okay? But as it is, we're just asking for the distance around the shape. So the distance around the shape, I know, comes to a total of 94. So that would be 2x plus 3y plus another 2x plus another 3y to be equal to 94.
Can you do that?
Yeah, that's all it's telling you to do.
What? I thought simultaneous equations could only have.
Okay, no. So I'm only putting.
you're gonna
I'm only doing
okay,
that so far.
right, okay.
You thought I was doing something for the other one as well. Okay, so 2x plus 2x, 4x. So this is actually going to be number 1. What I finish with now, and then 3y plus 3y, 6y equals 94. And for the other one, it's going to be x plus 6. Do I need it in brackets? Not really. I'm not timesing it, but I can keep it in brackets and make it wrong. And that's going to equal 56. Okay? How many x have I got? 2. So I've got 2x plus, how many y's? 2 y's. And then I've got 6 plus 4 plus 6 plus 4. So that's plus 20 equals 56. And then let's get that plus 20 onto the other side. So we get 2x plus 2y equals 36. Yeah. All good? Okay, and from there we need to just make the coefficients the same. So do I need to times both equations? No, I just times number 2 if it was me. Times number 2 by 2. We get a third equation, which would be 4x plus 4y be equal to 72. And then for 1 and 3, you've got matching coefficients. So if I do 1 take away 3, why am I going that way round rather than 3 take away 1? Any ideas? Good. Do I want a minus y? So 6y take away 4y gives me 2y. I wanted a positive y, it would have made things harder. 94 take away 72. 22. So then y equals?
So it's 56 times 2. Oh no, it's minus 20. Yeah.
All good?
Yeah.
It's alright, ask if you're unsure. It sounds like you've answered your own question. So now I've got y equals 11. How would I go and do the next bit? Good. Sub y equals 11 in 2. So we've got 2x plus 2 times 11 is equal to 36. Good. 2x plus 22 equals 36. So 2x equals 14. So x equals 7. Am I all done? Let's just check the marks. How many marks is it? 8. Isn't simultaneous equations normally like 4, maybe 5 if you have to form the equations like we did? You've got to find the area. I almost finished then. And it was only by going back and looking at how many marks, thinking, God, that's a lot of marks. Then I read it again. So right, I haven't done what it wanted. So find the area of each rectangle. So for rectangle A, it would be 2x multiplied by 3y. So 2 times 7, so that's going to be 14, times by 3 times 11, so 33. Oh, that's a mean question to give us on a non-calculated paper, isn't it? Grid method, Chinese method, whichever method works for you. I'm going to do Chinese method.
What's Chinese? What's the difference?
It's whichever one you're comfortable with. Don't change what you do. This is the one I'm most comfortable with, so that's why I'm using it.
462.
So 3 and 3 times 14. Have you seen this method before? No, even though it's been a poster up all the time you've been here.
There's a picture of it on Twitter.
Yeah.
We weren't good enough. You went here. Neither you.
Nor was I.
I was here.
I make it 4, 5, 4. But any method will do. Any method that you're confident with. Don't change it now, like I said before. It's a stupid idea to change now because You'll try and change it, try and do it in the exam, and it just won't work. And you think, oh, if I just used the method I'd always used, it would have worked. And then for B, slightly easier hopefully, it's going to be x plus 6 times by y plus 4. So x plus 6, that's 13, multiplied by 15.
So I got 462.
So I got 462 as well. So you're.
Don't use my method, it's the wrong answer. Right, I've spotted what I did wrong. That isn't 0, 4, that is 12. So that should be 2 and that should be 6. It should be 462. There we go, that's why it pays never to change your methods.
Or just never use that one.
Well, this one's really good when you get really good at it, so I still need to practice a bit more clearly. 13 times 15, I can sort of cheat because I know what 15 times 15 is off the top of my head. If you know that, great. If you don't, 15 times 10, just keep on counting up in 15, so I wouldn't bother going through the process of long multiplication. I make it 195. Is that right? Good. Redeem myself. Okay? Centimetres squared. Well done. Not on fire, so if you've got your exam tomorrow. Luckily, I haven't got an exam tomorrow, so I'll be dropping marks left, right, and centre, wouldn't I? Okay then, so where are we now? We've done well here. It's really only 10 o'clock. We've got a break at 10:30. Come on. We're not far off getting this done. We've done the line share bits. I didn't like this question in terms of explaining it. I always find this hard to explain.
Isn't it 180 by 62?
Oh, you lot got a really clever way of doing it. Yeah. Okay, 5, 4, 3, 2, and 1. Thank you. I'm definitely going to use the way that David just said because it's really, really clever. If you go and find the exterior angle, which is very easy, you just expand it. It's 18. Oh, the key word to say here is regular. Regular meaning same size, same angles. Then we know that one of the regular sides is 18. So 360, which is what all exteriors add up to, no matter how many sides, all exteriors equal 360. Divide it by the number of sides, so I'm going to call that n just for number of sides, but you can call it x, it's fine. And that would come to 18. Okay? Much quicker than what I was about to do, which was a lot fussier. I was going to work out how we got 162 if it was regular. This is much quicker. Bring the divided by n round to the other side, it becomes 18n equals 360. Take the 18 over, it becomes 360 divided by 18. Cover up the 0. What's 18 divided by 36? That's the wrong way around. I said that. 36 divided by 18. It's 2. Add a 0, so my answer is 20. So my number of sides is 20 sides. That's all. I've always done it a much more fussy way than that, Ruth, until someone here told me before. I was like, no, that's much easier. I'm glad you said it then. Cause
I usually think about it in triangles, though. Like, the shape's made of triangles. And so the bottom two...
Yeah, that's what I do. N minus 2 times by 180.
Oh, I don't put it in the formula. Like.
Yeah, I stick it into the formula, then divide by n would have given me 162, and I've worked out from there. It would have taken ages. Yeah, I can show you the fussy method if you like. The fussy method... Okay, nice and quiet, please. Thank you. The fussy method is to put it through the formula 180 n minus 2. Do you know what that equals? That equals your angles, your total angles in a polygon. So I don't know how many sides this has got. So I'm going to do 180 and then n minus 2. And then if I divide it by the number of sides, which will give me the number of angles, that'll come to 162. So then I would have expanded this bracket to get 180 n minus 360 is equal to 162n. I brought that divide by n round to times by. Then I would have brought this round to get 18n is equal to 360. And then I would have got n is equal to 360 divided by 18, which is 20.
So complicated.
Your way is much better, needless to say. Okay, so well done to David who said that he'd find the exterior because I was about to start gearing up through there. Okay. This one here, number 8. Oh, careful with this. People see some stupid answers here, which, like, honestly, you nailed the really hard probability question. You should be nailing this. Answers I commonly see here: 2 out of 12, 1 out of 12, 1 out of 6, 2 out of 6. Anyone get those? They're the common ones to have. What is the probability I get a 4? 1 out of 6. Chance I get a 4 again?
A 6.
What happens between probabilities? Times. So 1 times 1 is 6 out of 6. 6 times 6, 36. Okay? But it's really, really common that one's messed up, and that's why they probably put it in, because it commonly gets messed up. Yeah.
I did a question. It was like that. It was like which one's the 6? And the answer was that 1's 6 and 1's 6. It was like some of the complicated answer.
If you can find the question for you, I can have a look through it. And where are we now? We're on 14. Okay, so hopefully that was quite easy. That one again on our list. I miss. So no number at the front. That makes it easier. The one I've got on the board, I've actually put ax squared in. If it's got a number, it does make it a bit harder. But we're looking for a pair of numbers that times is to minus 15, and they add to plus 2. It's got to be a plus minus because
It's negative.
it's a negative. So it could be 50 and 1, it could be 1 and 15, it could be 3 and 5, it could be 5 and 3. Which one is it? Because
Adds up to 2.
that adds up to 2. So that doesn't. He's our man. So then you'd have it as x plus 5, x minus 3 equals 0. So either x plus 5 must be 0, or x minus 3 must be 0. So x equals minus 5, or x equals 3. All good? Simplifying out, the indices are the bits that people usually get right and they mess up the numbers. I quite often see 7, a to the 9, b to the 6. Why is it not 7? It's adding. It says 3 times 4. So 3 times 4 is 12. Add the indices, yes, but not the numbers. A to the power 3 times a to the power 6 becomes a to the power of 9. B to the power 5 times b to the power of 1. Very good, is b to the power 6. Okay, so easy 2 marks there if you're getting those. A comma? No. Why did I put a comma? When things are timesing, you just stick them together. Okay? Oh, question 9. Cheeky bit of trial improvements chucked in on a non-calc. Rude, isn't it?
Oh yeah, me and Maddie did this.
Are you sure?
We know the answer.
Right. There's only one way you can start. Go on, Paul.
It is from.
It is trial improvement. Yeah, that's the only thing
Just
I
looks
do.
like a very small space to be doing.
So, but me and Maddie factored.
Okay, so cubics. Bear in mind, 1 cubed is 1, so that's going to rule that one out. 2 cubed is 8, and then I'm taking away something, so I'm not going to try 2. 3 cubed is 27, that's looking pretty good. 4 cubed is like 64, so you can use a little bit of rationale there. So I'm going to try 3. And it didn't take me long to come to the idea of 3. So 3 cubed minus 2 times 3, that's 27. Take away 6, which is 21. Done. Okay? So find the integer. So I knew it had to be a whole number.
I'm quite lucky, to be honest.
Why?
The fact that you just like, oh, I'll just try 3 and then.
No, I didn't just magically pick it out though. I went rationally, didn't I? I said, look, when I tried 1 cubed is 1, so that's been way off. 2 cubed is 8, so still way off. 3 cubed is 27, so that's pretty close to 21, isn't it?
It took us like 15 minutes to do this.
Is it annoying seeing how quickly I did it then?
Like 7
Solve y squared. Now be careful with this. Y squared equals 7 is wrong.
It's plus or minus that.
It's plus or minus 7, so you should be saying y equals 7 or y equals minus 7.
So you couldn't write plus minus 7.
You can write, I would write it as 2 solutions like that. Okay? You write it like that at A level, that's a bit of a hangover from doing some A level. You make sure that's phones off, please. Expand the other one, or the one below it, C. That's not been your holiday alarm, is it? What's your alarm?
No, it wasn't me.
10 past minus 5 cubes. 5x cubed, sorry. All good? Mixed numbers. A mixed number is a whole fraction with a fraction. Is a whole number with a fraction. 4 3/4 and 2 3/8 are mixed numbers. There's a couple of different ways to do this. You could do 4 add 2 and get 6, and then deal with the fractions and add that on after. That's one way of doing it. It's probably my preference. Or you could turn these into top-heavy fractions and then deal with them. Which way would you prefer to do? Top-heavy. Okay. So 4 times 4, 16. Add 3, be 19 divided by 4. Okay. So 19 divided by 4 would give me back to being 4 3/4. Plus 2 times 8, so you do the big number times by the denominator, 16. Add 3 is also 19, divided by 8. But why can't I add those at the moment?
Because the denominators.
Denominators are not the same. Can that smaller one go into the bigger one?
Yeah.
Then just change that one. You don't need to change both of them. Some people would say, oh, times them together, and then you're going to get a common denominator. But you can get a common denominator by just doubling the top and the bottom here. So if I just double the 19, double 4, you get 38 over 8 plus 19 over 8, which is, add 20 would be 58, 57.
Yeah.
57 divided by 8, so how many 8s go into 57? 7 remainder? 1. What was I dividing by? So 7 and 1/8. Okay? All good? Cumulative frequencies, just page 14. Okay then, so 160 office workers. Can you see there in the question it tells you how many people are